This is Randy. This video is going to cover the programming of the firmware onto the electronics boards that go with the Ord Bot Hadron. It's a 3D printer. The kit that I bought was the Ord Bot hardware from RepRap discount, and when I bought it I went ahead and bundled and got their ultimate electronics kit as well. It includes essentially all the electronics you need to drive the printer, even without using a computer. I plan on using the LCD to drive it with the SD memory card. But this is the website for one of their auctions that I got the ultimate kit. And so this video is going to talk about this line here. We're going to program the Mega 256. So I've disassembled the two boards. They come attached together in the kit when they were shipped to me. I've disassembled it. I've got the Arduino board in front of me right now. And I'm going to plug it into the USB port of my computer. Before I do that though, I want to give credit to everybody that does this. This is not my original work. What I'm doing is I'm following the directions that the makers online have published, and this is really the result of a lot of clever work done by these guys. So probably the best page to start is the Ramps 1.4. That's what this board is compatible with. It's either an exact copy of this or a slightly modified version, but essentially it's a Ramps 1.4 board. So again, I've removed the bottom board, which is the Mega. Now on the Ramps 1.4 page, and this wiki is an excellent resource. It's got all kinds of information about how the boards are wired, the pinouts. I'm going to go down to the bottom, and from here I'm going to jump to firmware and pin assignments. Alright, so firmware. You'll need the Arduino software, so I'm going to start that downloading right now because it's going to take a few minutes to download. By the way, I'm doing this on an iMac that's a 2007, so it's not especially new. Go to the Arduino page, and I want the Arduino build 23, and that was specified. I've already dug through the Marlin software. The Marlin software says that, which we're going to download here, that we really want 23. I think, oh good, they say 23 right there as well. So, find version 23 on here. This is a Mac OS X, so I'm going to click on this download and start that downloading. Alright, while that's running, so that was this first piece of software I'll need. That'll let me program the board from my Mac, and there was Windows versions and Linux versions as well. Let's see. We're going to use, or I'm going to use the Marlin software. So, working firmware, you can download that prompt interface. So, following the Marlin link here, make a new tab. So I already had one. So here we go. Version beta 1 v1, current version. So here it says install version 22. Well, we're going to use version 23. Just copy the Marlin firmware image. Use the download button. Alright, so we're going to open this one to get the Marlin firmware. They use a version control system called Git to control it, and we're not going to go through the Git thing. We're just going to basically pull a zip file down of the Marlin firmware. Okay, so this is release candidate 2 for Marlin 1.0. Alright. I assume you could actually back up and get a different version. We'll take this one. So I'm going to ask it to get me a zip file. Alright, and those are both downloading. My Arduino download is finished. So here's the Arduino download. Alright, now I'm not going to put it in applications. I'm going to put it on my desktop. And I'm going to note that it is Arduino version 23. Now the first time I did this, I did not install the serial driver because I thought, hey, it's a Mac, it's already got the drivers, it should work. And I had problems, so I did go back and reinstall this driver. So I've already installed this on the Mac, and it I was talking to my old Arduino boards just fine without the driver, but I guess you need this one to talk to the newer boards or the Mega boards or this particular board. So I also pointed out, if you got a Windows computer, there's a special driver you need that they have on the RepRap discount site. So anyway, he's been installed, so I'm going to eject that disk. Okay, and I'm going to go up here and I'm going to name him Arduino 23 just so I know what it is. At the same time, I'm going to file, new folder. I'm going to make an Ord Bot folder, and I've already got my old one down there where I practiced. Ord Bot. Okay, perfect. And I'm going to take this zip file and I'm going to drag it over to the Ord Bot folder I just created. Okay. Back to our ramps. They have and this is a good reference page. Again, you should read this very carefully before you follow the directions I'm giving you, because I've already read it and tried it once or twice and gotten a few things wrong and learned. Arduino software, we don't need that tab anymore. Okay, so the rep wrap. So configuring and compiling. Install the Arduino software. Copy the Marlin firmware, so we did that. We unzipped it. Use the Arduino IDE. Select Mega 256. So let's go do that. Now that I have, as I said, I've already installed the driver for the USB, I'm going to plug the Torino board in, and it should have a bootloader already on it. So let's see, I launched the Arduino 2.3. Yes, I'm allowed to run this program. Alright, the first thing I always do with one of the Arduinos is we need to go to the Tools, Board. This is a Mega 256, so we want to change it to make sure that we know we're talking to the right thing. The serial port, it's picked the right serial port. I'm not going to change it. It's going to be different system to system. Alright, and I like to go to the Arduino Examples Basics Blink. So it's your basic Blink program. Okay, and I'm going to verify it should go fine. Upload it to the board. Alright, so the yellow LED, LED 1 I think in the middle of the board, is blinking for me now about once a second. So that tells me that I've talked to the board successfully, everything's working. And now that I've got that, they actually will tell you which file to open. So they want you to open marlin.pde. Alright, so let's say File, Open. Okay, we want to go to the desktop. Ord Bot. I did not unzip it yet, so let's unzip it. Okay, so let's go to the Marlin directory. Marlin, change this. Let's write my name. Open. I close Blink. Okay, now we have to make modifications to this this program before we burn it into our board. Okay, so we need to make some modifications to the configuration file that comes with the Marlin software. So a really good place to look for the stuff for the Ord Bot is the Ord Bot wiki. We're going to jump there, and so they've got the bill of materials, all the various pieces. We're going to go down to the software firmware. It's going to talk about the firmware that goes into the board. So we've downloaded the Marlin software, we've already got there. So this is the modifications we're going to need to make. Now, we're using a RAMPS 1.4 board, so we need to set the motherboard version to 33. And then we're going to need to set the stepper resolutions. So let's go to the configuration.h file. So we're in the Arduino software. Okay, I'm going to start just walking through here. Yeah, my baud rate on my Mac will not go to 250,000, so I'm going to drop it to 1152. Again, walking through the file, looking at it, motherboard. So, we have not defined motherboard 7, so we want to define it to 33. So rather than me blindly just going through the file, let's look at what they say. So in the motherboard, the resolution, okay, extruder. I think that's the basics I need. Now we did one other thing though. So we've got the LCD panel, and I'm going to be driving from the LCD panel. So rep discount ramps config, and here it is, the smart controller. So we need to make some changes to the config file to support this smart controller, and it tells us what it is. Let's see, configuration H. So motherboard 33, we already did that. Change 306, rep smart controller, so line 306. And I don't think they have line numbers in here, so I'm going to just keep going down until we find the smart controller line. Okay, so it's using a definition here and it's getting it here. So we have the wrap discount smart controller. So let's uncomment that line. Let's see what else they tell us to do. Change line 326 to pound define new panel. Then you have the click encoder panel. All right. So if defined or if defined or if defined. So it looks like it's defining new panel for us. All right, so we don't need to worry about that one. Okay, so we need to go edit the pins.h, line 318, ramps V13. Okay. Ramps V13 and pins.h. Alright, it says we're good to go. But we're going to go ahead and make a few more changes while we're here. So let's go back to configuration.h. And I skipped over it a minute ago, but here we go. Default settings. Default axis steps per unit. So I counted the number of teeth on the gears for the stepper motor on the belt drives, and we have 18 teeth on the gear that come shipped assembled. Now they give you extra belts in the Ultimate kit and extra gears. I may switch to those eventually, but I want to stick with what I have now. So those gears have 18 teeth on them, and I also used a caliper to measure the spacing from tooth to tooth on the belt, and it's 2 millimeters. So I've already edited stuff in an Emacs file. These lines, edit, copy. Okay, and I'm going to paste them in after their definition. So I'll get a little blank line here. I'll say edit, paste. Okay, I'm going to comment out their definition. So I got 2 of them now. So I went ahead and put the equations in line so you can edit the equations instead of doing the math to calculate it. But 360 degrees divided by 1.8 degrees per step times 16. And I did look under the Palo stepper driver boards on the ramps board, and they have all of the jumpers in place, which means you're doing 16 microstepping. So every 16 pulses, the stepper will go 1 full step. 1 pulse sends it a 16th of a step, so it's using pulse width modulation between the coils and the stepper motor to do microstepping. So they were set for 16. And in the belt drives, there are 2 millimeters per tooth, and there are 18 teeth per revolution on the wheel. For the screw drives for the Z's, again 360 divided by 1.8 times 16 microstepping, and it's a 8 millimeter lead screw which has a 1.25 millimeter pitch, or it's 1 revolution brings you up 1.25 millimeters. So default steps per unit is underscore belt steps per mm underscore, which is this macro here. Again, that's X, this is Y. X and Y both have that. Z has underscore screw steps per mm, which is this macro here. Hopefully it'll calculate all the math correctly. I left the extruder step rate alone. I didn't touch it. I'm going to leave the feed rates alone as well. And with all of that done, I'm going to try to do a test compile, so verify. I don't know where those came from. I hope I didn't paste them in. Which file was this in? Configuration.h. Okay. And we are going to upload it to the board. Alright, upload done. So we're going to do one more little trick. We're going to go to the serial monitor, and we've got the baud rate as I said earlier. Look, start echo reset. So it looks like the board is booted, is running, and is sending stuff out the serial ports. That's a good sign. Alright, well, I'm going to go back down to the machine and plug the boards back up now that's been programmed.